here is the body of any shape. Here I have taken the rectangular body, but you can consider it is a body of any shape, because the perpendicular axis theorem I am going to discuss today, it is applicable for all the shapes. Here I got the three axes. One is the x-axis. The body can rotate about x-axis, or the body can rotate about even y-axis, or the body can even rotate about z-axis. First of all, let us see the rotation of the body about x-axis, y-axis and z-axis. Now the body is rotating about x-axis. Now body rotating about y-axis, and now body rotating about z-axis. X-axis, y-axis and z-axis, they are concurrent axes. Since all the three axes are meeting at one common point, therefore they are concurrent axes. One more important point to be noted, that x-axis is perpendicular to y-axis and y-axis perpendicular to z-axis and z-axis perpendicular to x-axis. Therefore, three axes are mutually perpendicular to each other, as well as they are concurrent axes. X-axis and y-axis are present in the plane of the body, and z-axis is perpendicular to both the axes. All the three axes are concurrent. These three axes are concurrent at point O. Now, let Ix be the moment of inertia of the body about x-axis, Iy moment of inertia of the body about y-axis, and Iz equals to moment of inertia of the body about z-axis. Here I have shown you the three different types of rotation. The body rotating about z-axis, body rotating about x-axis, and body rotating about y-axis. Moment of inertia about z-axis is denoted by Iz, and moment of inertia about x-axis denoted by Ix, and moment of inertia of the body about y-axis denoted by Iy. Now consider an elemental mass dm present at point P. Draw a perpendicular from point P to x-axis, that is Pm perpendicular drawn to x-axis, and draw another perpendicular Pn from y-axis. So Pn equals to perpendicular drawn to y-axis. Now join OP. So distance OM is equals to x and distance PM equals to y. So distance PN equals to x and distance PM equals to y. Now it is a right angle triangle. Therefore distance OP equals to under root of x square plus y square, implies OP square equals to x square plus y square. Now moment of inertia of entire body equals to distance of dm from x-axis, square of this distance, square of distance of dm from x-axis multiplied by dm, implies Ix equals to integration distance of dm from x-axis nothing but y, that is distance pm. Therefore here y square will come and dm. Therefore integration of y square dm nothing but gives moment of inertia of the body about x-axis. Therefore Ix equals to integration of y square dm. Call it equation number 1. Similarly, Iy nothing but moment of inertia of entire body about y-axis. So moment of inertia of entire body about y-axis, that is equals to Iy. That is equals to distance of dm from y-axis square of the distance of dm from y-axis multiplied by dm. Distance of dm from y-axis nothing but equals to x. Therefore, Iy equals to integration of x square dm, that is moment of inertia of entire body about y-axis, equals to Iy equals to integration of x square dm. Call it equation number 2. Now Iz be the moment of inertia of entire body about z-axis. So moment of inertia about z-axis equals to distance of dm from z-axis, square of it, square of the distance of dm from z-axis multiplied by dm. So Iz equals to integration op square dm. Iz equals to op square dm, integration of op square dm. Iz equals to integration op square nothing but x square plus y square with respect to dm. Now separating integration, Iz equals to integration of x square dm plus integration of y square dm. From above expression, x square dm is nothing but Iy and y square dm nothing but Ix. This can also be written as Iz equals to Ix plus Iy. This is nothing but mathematical form of theorem of perpendicular axis. From above discussion, we can now define perpendicular axis theorem. Moment of inertia of a laminar object about z-axis which is perpendicular to both x and y axis. X-axis and y-axis are present in the plane of laminar object. All axes are concurrent. Then moment of inertia about perpendicular axis is equal to sum of moment of inertias about two mutually perpendicular axes in its plane. Therefore, Iz equals to Ix plus Iy, where Ix equals to moment of inertia about x-axis, Iy equals to moment of inertia about y-axis, and Iz equals to moment of inertia about z-axis. Now, let us test your understanding. For a flywheel, moment of inertia about x-axis and y-axis is equals to 2 kg/m square. Then find moment of inertia about z-axis. Please write down your answer in the comment box. Meet you again with another topic. Till then, wish you good luck. Before saying goodbye to you, I would like to request you like, share and subscribe the channel. Meet you again with another video, another topic. Till then, wish you good luck. All the best.